All right, in today's video we're going to look at some methods that we can use to estimate cover of species for a monitoring program. And it's probably important to keep in mind that the focus of this is on monitoring as opposed to specifically getting cover for a lot of different species as more of an assessment. So the focus is on something that we can do quickly that gives us information about change. Hello, I'm Pat Johnson. I'm with South Dakota State University, the West River Ag Center in Rapid City. We're out here today with Roger Gates, who is one of our he's our range extension specialist here in Rapid City as well. We're at the Cottonwood Research Station. And what we're doing today is to demonstrate some techniques for estimating cover. The techniques that we'll be using are some point samples as well as some plot samples. And we have our trusty graduate students back there who are out here helping us with this video. They come out in all sorts of weather and have done quite a bit of work this summer on some other things, but thought it'd be interesting to teach them some of the techniques that we have to use for cover for monitoring.
And you said there were at least two approaches to that. One is a point cover estimation, the other is a plot estimation. Could you tell us about why we might be interested in one or the other of those approaches?
All right, especially for doing monitoring, the point sampling provides us with a very objective measure. So it is or it isn't a hit, and it's very quick. It's something that is very easily done. It doesn't take a terrific amount of training for someone to teach. The plot methods require a little bit more time. And they're something where you put a plot frame on the ground and you have to estimate with your mind, use your eyes to decide what percent of that is covered by the species of interest. The point sample, you just add up all the points that are hits on that vegetation, divide by the total number that you sampled, or multiply by 100, and you get percent cover. The other, you have to actually come up with a number yourself. And so it's much more subjective when you use plot techniques. But they're also very, very good. People are actually very good at it. We get much better data with people on these ocular estimates of cover in plots than most people think they can provide. The goal when we select species to monitor, regardless of the technique that we're going to use, is to find species that are good at indicating change. So if we implement a management strategy that will ultimately increase some perennial grass species, for example, then we'd want to focus on either that or a decrease in something that we would expect to decline. There may be some very, very important species that everybody's interested in, like a rare species, but generally those are not good to follow because they simply don't change enough for us to be able to evaluate whether anything is happening at the plant community level. The first technique that we're going to try out here today is the step point. And it is a technique that requires that there be a point on the end of someone's boot. Generally, if you do it a lot, you'll put a notch in the end of your boot. If you don't, you might then just put a dot with a marker of some sort. And then they walk a transect, and every time they put that foot down, they look to see whether or not that point on the end of their boot is intercepting the species of interest. So why don't we go ahead and get started? Come on over. Who'd like to be our first? All righty. So Christy, what you're going to do is this is your baseline, you're going to walk a transect perpendicular to this baseline, so you're going to head up the hill. And every time you place your right foot, don't place it, don't pick your place, just walk naturally. Then you're going to look down and see if that point that we put on your boot is intercepting a short grass, buffalo grass or blue grama, and mark it appropriately. So you'll be in Transect 1, and you'll do 50 samples. So you'll fill out this side and then flip it over and get the other side of the page. All right, so why don't you go ahead and get started and pick a point up the hill and decide where you're walking and see what you can find out. Probably the most important or most difficult part of doing this technique is deciding whether or not you actually have an interception. You have a point on your boot. Sometimes the vegetation is under the boot, sometimes it's over the boot, sometimes it's touching that the tip of the boot. And really the best way to think about it is a vertical line going straight through that point, and if the vegetation of interest touches that vertical line anywhere from your eyeball down to the ground, then it's an interception. If it does not, then it's a miss.
Jana, if you could just pause right there. This is Jana Kinchlow. She's part of our multidisciplinary team. Jana's a research extension associate and also a PhD grad student pursuing a degree in animal science. So Jana's making progress on her transect, but we want to visit about whether or not you actually make an intercept with that point on the end of your boot. So, and in this case, that's intersecting a leaf of buffalo grass, so in this case, it's a hit.
All right, if you want to hold up there for a second, Ben. This is Ben Turner. He's a PhD student working in biological sciences. Want to stop for just a minute and talk about the different kinds of cover that you can sample for using any of these point samples. We have been talking about foliar cover, so we're looking at any part of the plant from the base up to the leaves and reproductive parts. That particular cover does vary considerably from one year to the next, especially in regard to precipitation. So if you have a lot of precipitation, you get more foliar cover. One type of cover that's much more stable is basal cover. And the cover values are always quite a bit smaller and sometimes a little bit more difficult for people to distinguish, but it's a valuable estimator of cover. And so we'll take a look in this case as to whether or not you've gotten a basal hit with your toe, with the point on your toe. And in this case, we have a buffalo grass that intercepts the base of the buffalo grass. Actually is an interception with the line coming down through the toe of his boot. Well, when we do point sampling, every point gives us one of two answers, yes or no, a hit or a miss. And so that's binomial data, and that by and large, or that in and of itself, does not tell us percent cover. What you have to do then is to look at the entire transect, and if you have 25 hits out of 50 placements, then you would have 50% cover. So we use the data to create a value that we call percent cover. And so the raw data give us that percent cover. You take the sum of all the hits, divide by the sum of all the points that you put down, and multiply by 100, and that gives you percent cover.
So some of the advantages of the step point method are it's really convenient. It's pretty easy to use an indicator at the tip of your boot, and that's with you most of the time. You can accumulate a large quantity of data in a pretty short period of time, just stepping a transect and accumulating information very rapidly. I think probably one of the major drawbacks of this particular approach is the inclination for the observer to introduce some bias. They may be particularly interested in a particular indicator and may tend to walk towards that kind of thing. The other difficulty is that the point is really dimensionless, and the tip of a boot has some dimension associated with it. And so again, the potential for a little bit of bias depending on how strict the observer is about following the protocol that's involved. So Pat, we're trying to be very objective about our measurements. One of the tendencies for somebody that's doing a pace transect is to look for the kinds of things they'd like to see, and that could bias the estimate a little bit. So this is another device, a different approach to the same kind of principles, but why don't you tell us about what it is and how it might help alleviate some of that bias that's potentially out there?
It's very, very simple. When you take your last step, put this out in front of you, you can push the button, and what it does is it focuses a laser point on the surface below. So if that red dot appears on the vegetation of interest, it's a hit. If it does not, then it is a miss. And very, very simple. It reduces the subjectivity, because while you may direct your foot and you can put this out in front of you, it's very difficult to direct this point when it's out in front of you at arm's length. We're standing in another pasture at our Cottonwood Research Station. This particular pasture has had long-term light grazing use. The pasture with the shortgrass plant community has had long-term heavy grazing use and has been converted to a shortgrass plant community. Here we have more of the mixed, where we have some of the shortgrasses and a lot of the midgrasses. And when we're doing point sampling in this kind of a plant community, it's a little bit more difficult than in the shortgrass, because as you walk, if you're doing the step point, as you walk, one thing happens is that you're stepping on your sample, and the sample will tip over, and so deciding on a hit there is a little bit more of a judgment call. And then also very often the point of your boot is going to be hidden in the grass, and so you have to kind of carefully pick down to see whether or not you actually have something in that imaginary line that's running down through the point on the tip of the boot. So for example here, if Christy takes a step and she steps in there, and if our target species is, say, the western wheatgrass in this case, then we do have a western wheatgrass tiller right by the tip of her boot, and so we would say yes, she has a hit. However, what she's done is she's actually tipped the plant over, and so it's no longer lying in the same plane or in the same volume that it had been before she stepped on it. And that's one of the difficulties with the step point technique, is that you actually alter the structure of the vegetation.
So Pat, what's the alternative? The step point's really convenient. How do we avoid the change in the vegetation that entails?
Some of the point sampling methods that we have available to us, I think, can provide us with some alternatives. This laser pointer, so instead of her stepping there, we can put this out in front. This is not going to change the architecture. All right, the first hit is on this leaf right here, and we would want to move it aside to see if we're getting down into the lower part of the vegetation. Are we getting into the shortgrass plant community? And you can see that as we go lower, we actually have hit one of the shortgrass tillers. But here we hit a western wheatgrass tiller up in the top part. So we move it aside so that we can see if we actually get to the shortgrass. The laser point technique provides a number of advantages over something, say, like the step point. And it's a very objective method to use. It creates, we can get a large data set very, very quickly. One of the disadvantages to step point that you avoid with the laser point, and actually any of the other devices, is that we're not stepping on our sample and altering the architecture of the plant community. We are actually seeing it as it normally stands. It's very quick. People are usually very quick to pick up the technique. Disadvantages, this is one where you have to carry some extra equipment around, so you're not just carrying your clipboard. You do have some issues. Anyone who has some color blindness issues may not be able to see the point very clearly, and that can be a real critical problem. It's still something where you can direct yourself a little bit. You're not as likely to get exactly what you think you'd like to see, but if you've got a patch of cactus, you still are probably going to have a tendency to skirt around it. So it's not perfect, but it does give you some advantages over some of the other techniques, such as the step point.
So Pat, we've displayed the use of the couple of uses of the point intercept approach. We did those with a paste transect. We're also going to talk about the line point approach. With a line transect, we also have to make a choice whether we're going to do it systematically or use some kind of random approach. How important is that in the sampling?
You can have random locations, so you can take the first time you put your foot down, you take a sample and then you go 10 paces. You can randomize that. The value of it in terms of creating that cover estimate for that transect is pretty minimal, especially compared to the problems that creates for the sampler. So the real key is to make sure that you have random transects. All right, what we're going to do here is to use a line point sampling technique to get at cover, and we've established a transect with a tape. This particular tape is measured in metric units. You can use feet or anything else. And before you go into it, you decide that at every 10 centimeters or 1 meter or whatever, you are going to look for an interception. You can do it a number of ways. You can simply walk over it. Let's say that we're going to do it at the 1 meter. You can walk over to it, look straight down on that one point and determine whether or not we have an interception. You can use a point and you can just run it along that tape. It helps if this tape's a little bit more rigid if we're going to do that. And you look to see whether it hits or touches the vegetation of choice. And in this case, if you had a multi-layer grassland vegetation, you would continue through the canopy until you hit bare ground, because if you have a lot of western wheatgrass, for example, here, it may be covering up the shortgrass, which is our target species. So generally you would probably do 30 to 50 meters so that you get 30 to 50 sampling points, and moves along pretty quickly. So why don't you go ahead and get started? Which technique would you like to use?
I'll take the pin drop.
All righty, so I'll take this.
So there is a trade-off between the investment, the cost of doing a line point observation, and the accuracy with which that information is ultimately gathered. The more points you can collect, and in this case we're talking about using a transect, so the transect, the average on the transect is actually the observation. And so you have to do multiple transects in order to accumulate quantitative information. And the trade-off is simply the more transects you do, the more accurate the evaluation is, but the more transects you do, the longer time, the greater cost is involved.
The line point sampling technique offers a few advantages over some of the others. It certainly is a very objective technique. The pins can be left in and you can come back and resample the same area. You will never be able to get exactly the same points each time you come back, but you're in the same general area. You can use a variety of techniques, whether you just simply look down at the point. You can use the laser pointer, you can use a pin. So you have a variety of things that you can use along with the line in order to get at a good point sample. And it's relatively fast. You go every 1 meter, every 10 centimeters, whatever you've chosen, and you can get a very fast sample. It has similar issues with any of the other point samples. Your point is technically supposed to be dimensionless. None of our points are. So anything that whether we have a pin, whether we use a laser pointer or whatever, we typically have a larger point than we would like to have. It's not repeatable. If you absolutely need to have something that's repeatable, this is not one that you want to use. If you have any wind in the area, the line may move around a little bit. That may make it more difficult. And again, you can still direct the pin or even direct your other equipment so that you get a hit where maybe you shouldn't have. A lot of times people just, I know it's there, I haven't hit it yet, so gosh, it's awfully close. It probably is. We can justify that, and sometimes we create a little bit of data we shouldn't.
Pat, we've demonstrated some of the point techniques for measuring cover. There are also some plot techniques. Would you distinguish those and tell us a little bit about what we're going to demonstrate?
As we did these point techniques, we had everybody work within transects, and the accumulation of information in a transect then yielded an estimate of cover. When we use the plot techniques, each plot itself gives us an estimate of cover. Now, one can put these plots in transects, but when you do that, then the transect again becomes a sampling unit. So what we're going to do today is to look at some randomly placed locations. We're going to put plot frames on them, and we're going to look at two ways of estimating cover using plots. One uses classes, and in this case we're going to use Daubenmeier classes, and these are already set up. They're distinguished as particular levels of percent cover, go into class 1, 2, 3, 4, and 5, and 6. And then we'll also use some quarter-meter plot frames and estimate using ocular estimation, which is something many people are uncomfortable with at first, but it turns out that many people are actually very good at doing. All right, Chris, do you want to go ahead and put that Daubenmeier plot frame down on the plot? A Daubenmeier plot frame is a 20 centimeter by 50 centimeter plot frame. You actually can use these Daubenmeier cover classes with any size plot frame, but we're going to use the Daubenmeier here in this case. And what you're doing is you're looking at this from above, and you're asking what percent of this plot is covered with the target species. In this case, it's going to be the short grasses, the buffalo grass and blue grama. And rather than having to come up with an actual percentage, you put it into these classes. So you look down at it and you ask, is it less than 5%? If you thought it was less than 5%, you would put a 1 as the cover class. If you thought it was between 6 and 25%, then you would give it a cover class 2. 26 to 50% is a cover class 3. 51 to 75 is 4, 76 to 95 is 5, and then greater than 95% cover would be a class 6. All right, what percent cover class do you think this vegetation represents?
I would choose cover class 4, 51% to 75%.
So you're seeing it as being more than half, but not more than 3/4,
Yep.
right? Got your pencil?
No, who has my pencil?
I stole it.
Just never uses her pencil.
I think someone stole it.
I stole it and gave it to Pat.
Now I gave it back. All right, now we're going to switch to looking at ocular estimation without any of the cover class estimators. So in this case, we're going to actually do an estimate of what we think the actual cover is. So Jan is going to help us with this. She's got a quarter-meter plot frame, which is typical of what we use in this particular ecosystem. And the trick here then is to stand over the vegetation, and instead of putting it into a cover class, you've got to decide about what is the percent cover of the shortgrass species in this particular frame. And there are lots of mental gymnastics that you can do to try to figure that out. You can mentally cut the frame in half and ask, if I were to move all the vegetation over and not change not overlap it any more than it already is, would it be about 50% cover? And if that's still a little bit too much, you could quarter it and say, okay, if I moved it all into a quarter. So it's a visual observation, and over time you get pretty good at this. So you can kind of move the vegetation around mentally and see if you can come up with a number. So take a shot at it.
Looks about 45% to me.
All right.
So when you're using a cover class approach with plot technique, you've assigned a numerical value to each of the cover classes 1 through 6. In order to get a numerical average, you have to assign some numerical value to each of those cover classes. So for instance, if the cover class is between 25 and 50%, you would assign the midpoint, which is 37.5%, and use that in your calculation. That potentially introduces some error, some lack of accuracy, because you're arbitrarily using the midpoint as an average value.
We find a lot of people are setting up monitoring, and this can be done on private land. It's done oftentimes with public land. A lot of the public land management agencies are doing what they call monitoring. And monitoring is something that we do over time. You can get some information in year one, but in order to actually do monitoring, you've got to do it over time and find out whether change is occurring. And very often we find that people do so much data collection in each year that it becomes prohibitive for them to go out year after year after year to collect the data. So if you're going to set up a good monitoring program, you need to set up something that tells you what you need to know with as little data collection as possible, that can be done as quickly as possible with the people who are available. So if it's going to be a rancher, you're going to have to keep in mind that they will have maybe a half a day, maybe they'll give you a full day once a year. So you've got to tailor a monitoring program so that they will get as much as they can out of it, consider their species ID skills, and make sure that it actually can answer the question. So it's something that monitoring needs to be developed to be something that is done quickly and gives you as much information about whether change is occurring. And generally, what you'll do is you'll do a full assessment. That's the expensive thing up front. This is what we have today. You set up a monitoring program, you collect specific smaller bits of information over time, and then once you've determined that change has occurred because your monitoring is telling you that it has, then you go back and do the expensive assessment at a later date. But to go and do assessment every year is extremely expensive and probably not very wise.